Speaking of reliability, a podcast with good friends talking with you about reliability engineering topics. Welcome to Speaking of Reliability. This is Fred Schenkelberg.
And this is Kirk Gray.
Hey, Kirk, have you ever made more than one thing? Created a design and made like 1,000 of them or 10,000 of them or 100,000 of them? Or you worked at a computer company. You did stuff like that.
There's definitely companies that I worked at made millions sometimes of things.
And there's a good, so this is based on a question I got last week. And it was more about how do you go about, from a reliability point of view, how do you make sure that the first product you make and the millionth product you make, to paraphrase what you're talking about, are going to be, as close to the designed intent or the reliability of what our design is capable of? How do you, because we all know that no two products we make will be identical, and there is going to be variation. But that's not the only source of failure in the manufacturing process, not just the variation. It's all kinds of things that happen. You could call it variation, but.
Right. And there's a whole bunch of ways to address that. It's a lot of, of course, as everything, it's dependent on a lot of factors. It's, are you using a contract manufacturer? Are you manufacturing in-house? And, your supply chains, those kind of things that are consistent. Of course, the godfather of process control, Edward Deming, Dr. Deming, taught statistical process control, where you'd monitor your processes and look for variation in the processes or the end result. And anytime you start to see the processes excursions come out of control, you stop the process and understand what's causing the variation, and get it back into, which would be Six Sigma process capability, where every part is so far from within spec that that as the assembly is being made, it's very consistent. And
very
that's
consistent,
the whole point.
And robust to all the variation it's going to see in use and all those kind of things. Yeah.
But behind all that, their dynamics are happening all the time in electronic manufacturing. That is, components are being discontinued. Procurement is trying to find less costly components, maybe even less costly manufacturing facility. They'll argue that these changes don't cost anything and save money. Many of them may do that in the end, but there are a significant risk in every one of those, especially changing a location, changing a supplier, without evaluation of that before it is put into place, can lead to disasters. And I've seen a few. A company changing the location of where it manufactures a component or a sub-assembly can significantly change the capability.
Yeah, I had a problem where they said, we moved to a new location, but we took the equipment and we took the people. And so it's exactly the same. He says, it's not showing up here because like 1 in 3 are failing now.
Exactly.
Something's
we
changed.
went from a high humidity environment to, or a low humidity, whatever.
We're electrostatically, zapping everything we touch.
I'm sorry. You can't do that and make it identical. It's.
But the basic question is that, it goes from one absurd to the other. One is ignore it and wait till you get stuff back from the field, and then do the root cause, and then go either fix the system, the manufacturing process in your supply chain, so that problem doesn't happen again. But you're going to be doing whack-a-mole for your entire production run.
Or the other extreme is to test 100% of them
to failure. To failure, so you never ship anything, but you'll know which ones are reliable or not.
Well, I don't know to failure, but
otherwise you don't know.
Let's say high levels of stress, or using a HASS, highly accelerated stress screen, or something like that, which is very expensive.
It's expensive, but it's effective for doing a pretty broad brush on all kinds of mechanisms that
It
are
is.
common to manufacturing, electronics manufacturing in particular.
And it's comprehensive. It takes the whole assembly usually and stress, all the interactions that you couldn't see or observe or visually inspect or things like that. And, maybe at the last step of the manufacturing assembly process, somebody didn't plug a connector in, things like that. Those are common issues.
So let's
but
use
that's expensive.
But how about a completely different approach? Because end of line testing it's after the fact. We're sorting at that point, and sometimes our sorts are better than others, right? We can measure voltage and bin them in different ways, or we do HAS and say, this batch is bad. Now we got a week of production we got to deal with, or an hour of production or whatever. But the Deming stuff of monitoring in line and stuff, but I've run into people that go, well, we're monitoring the solder paste deposition, the height of the solder paste.
Yeah.
Okay.
Right.
Why? Well, because we can. Have you had problems with it?
Where's that led a problem? Where have you seen a problem with that in the field? And if they can cite, we had a problem with that in the previous product, then good. They have some motivation and reason. But if it's not,
this one got even worse though. It was, well, what do you do when you find that it's not a couple of the pads are not deposited? So there's no solder there for the component to be connected. Oh, we run it all the way through and we'll catch it in rework later.
Oh my God.
So we alert the people for rework where to add solder to it. Oh my God, this is horrible. So anyway, how about a process where you work with the design team and you're doing prototypes and you all cross your whole team for all the different reasons we make prototypes, and you keep track of what kind of problems come up, right? And some of them you're actively trying to design out or fix or address or whatever. Right. But invariably, there's going to be some that, this one is going to be a very large source of problems just because the nature of the manufacturing process is not controlled. It's hand done. Right. My favorite was somebody took a syringe full of this adhesive and had to apply it into this ring for this mating part to come down into it.
Yeah.
And we knew in prototyping that if they only went 2/3 of the way around that ring, or they had gaps in it and stuff like that, these parts would come apart real easy. If you just tapped it with your hand, the part would come apart. And so they installed a automatic dispenser to make the full ring of it.
Right.
And it tested out really great. And I, of all the things we ran into, that was the one that had the highest risk, because it didn't take much variation for it to go bad. If the adhesive was too, if it was old adhesive, it went to hold. If it wasn't enough adhesive applied, if there's too much adhesive applied, if the components were dirty or had contaminants in it, it went to adhere. And it was just one of those things. The team and I said, that's an area we really need to monitor.
How about that's an area that we can improve through a design change, or
they kind of is a cheap consumer product, game controller type thing. And and they were like, no, the solutions for this would cost us way too much to fix it. So we just got to count on this adhesive thing. And I said, well, if it's done well, it's fine. But if that process, if you train the next guy and that guy trains the next guy and that guy, it's kind of whispering the directions to the next person, which was what their technique was. That recipe will probably erode. That process will probably degrade. And so we need to monitor that one.
Right.
What about all these other things we typically monitor? Well, we don't see problems with them. We haven't seen problems with them in the field after making millions of similar products. Now, let's skip that stuff. Let's just focus on this. And I think there were 2 or 3 other areas that were considered pretty high risk that were going to lead to major problems. And sure enough, 2 weeks into production, these parts started coming apart with very simple drop tests that we had. And it was like, okay, let's walk upstream. Well, they added 2 more lines for doing the adhesive by hand.
Yeah.
And okay.
That was it.
Stop doing that. But we had to throw away 2 weeks of production.
Wow. That's expensive.
Yeah. And I was trying to convince them, no, let's monitor every chef's production. And they're like, oh, that's too expensive. All right, well, throwing away 2 weeks worth is really expensive. So,
right, and it's all of this is an insurance process after the fact. If you can't, if you have a fundamental limit of technology that you really can't make more robust, then you are, dependent on
process stability and process
processes,
improvements.
right?
Yeah.
Process stability, process monitoring, those kinds of things. But
They're really a
it's an
fallback
insurance.
position, right?
It's all insurance that
Yeah.
you're trying to protect yourself from a future event, and you're betting that you will prevent it and catch it. But just like anything, the unexpected can happen.
Oh
And,
yeah, a new component
usually,
shows up and you don't know it's changed or
right. And because you can't go back the depth of the supply chain just for an IC. You've got the epoxies, you've got the lead frames, you've got the silicon, you've got the wire bonds, you've got all that stuff that each one of those suppliers, and they're all different, could change. And at the final assembly being the
first time you recognize it's not working,
yeah,
or worse, when it gets to the
right.
field.
Exactly.
Yeah.
And
No,
so,
and the argument is that it's not feasible or economical to check everything. It's
right.
that axiom of, well, if I test everything to failure with all failure mechanisms, then we'll know, right? But
right.
no, we're not going to do that. So we back up and we say, what's the most likely things that we need to check? Where's it most
right.
likely to cause problems? And then we can only go so deep with that before we're testing everything or screening everything. And even the most automatic screen in the world is not perfect. It's going to have false failures, right. And it's going to have false negatives or false positive, false negatives. So we're going to ship bad products to some extent and scrap good ones.
Right.
But if you focus only on process monitoring, like the Deming in control charts and all that kind of stuff, well, there's a diminishing return there too. Is, well, which areas are critical? What should we be measuring that foretell future problems that are of high risk to us? And some
right.
people are really good at that, but others put it in place so that when they do a tour of their line at a contract manufacturer and say, hey, we measure solder paste and we measure this temperature and we measure this. I'm like, why? Oh, it's because we can. Or it makes it look like we're doing really proactive stuff here.
Right. And the problem also with any of these measurements and any of these inspection processes or HACCP and any kind of ongoing reliability test or inspection is that if for a long period of time, nothing comes out of it, your manufacturing is good and excellent and capable, it gets really kind of like, hey, we've done this, and you get really lax at it. Mm-hmm. And that's when the problems begin. People say, why, and the SPC charts become wallpaper and they're all in control. And people didn't say, well, what is the benefit of all this? Because all of our manufacturing has been in control and we haven't had any field problems. Well, gosh, congratulations. That's wonderful. But you paid a lot, just like if you pay health insurance and you never get sick, mm-hmm. Maybe it's a bad bet. I don't know. I'd still like to stay on the side of, maybe I could get cancer and that could sink me, but I don't know. We don't know. So it's like anything. There's a trade-off that you do, but you've got to realize the human element involved gets pretty bored when they're measuring and measuring and measuring and measuring and the same results come out. Yeah. And there's no why am I doing this?
Well, there's I think two responses to that. One is the basic approach is, one, don't test everything, and two, don't test nothing, kind of thing, be completely reactive. But focusing on the areas that are deemed highest risk, most likely to cause problems and or be highly uncontrollable or not in control. And continue. And the second part of that is the continuous improvement. Just because you're doing good now doesn't mean you can't get better and improve yields, improve, the precision of each product that's made and its performance. Those will all have long-term benefits, which is very hard to see when you're running a manufacturing line because you're looking at filling trucks, not tweaking your line.
Everybody's trying to, your procurement's trying to improve the supply chains, whatever. But in all of this, you should know during your design testing, and of course we both encourage testing to find limits, to find the weaknesses early. So you should have some indication, either from also your predecessor products, issues from the field. Those areas, those key process indicators are key parameters that you need to monitor. And as you said, you can't monitor everything, so you pick out some very key things that either have been a problem in the field or are difficult to control in manufacturing and need that monitoring.
But even with a lot of focus on right from the design part of the life cycle in through manufacturing is in putting safety nets or guards or measurement systems in place, and even pulling samples and doing ongoing reliability testing to failure kind of things. You still have to be vigilant for what happens when your customers actually get a hold of the product, and don't wait for it to filter through all the various layers before it gets back to you. And I've seen this very effectively done in consumer products and workstations and a couple other products where they deliberately take a part of the team from the design team. So an electrical engineer, mechanical engineer, software engineer, and so on, a handful of folks. Yeah. And they put them in a real close to the customer service or the repair center, wherever field problems first get identified. Yeah. And then they make a Herculean, who's that? Herculean effort to get as much information about the circumstance and environment of how the failure was found or what happened and that kind of stuff, and get the product back. And they would ship out the new product and get them the product back, even relatively inexpensive products. They were really diligent for a couple of months. And then that team would do a detailed failure analysis and propose, and they were part of the design team and key people in it. So they knew the design, they knew what was possible and not possible, and they had a fast track to put changes through. And every place I've seen the team, and they invest 5 engineers, talented design engineers, for 2 months to super speed up the fixing field issues. Not only did it reduce the field failure rate, but it reduced it faster and lower than in their previous products, where they would wait for customer service to say, "Hey, here's our Pareto from the last quarter. We think we have a problem here,"
right?
Kind of thing.
Right. And that's great. I mean, that sounds like an excellent company. That's what they should be doing. Either they do that, plus, of course, the halt testing before they go to the customer, but then putting in, and, they're never going to know when a customer is going to put it into a new application or a new, sometimes a new condition without telling them.
Yeah, what do you mean I can't throw this in a pinball machine and let it bounce around? It's perfect for that.
Yeah, exactly.
I'll just make this big dice and throw it in a big old basket that bounces around all bunch. We'll see what happens.
But they, pinball machines were illegal in New York and for a long time. And
just a lot of regular pinball machines?
Well, it was the early
ones.
Pinball machines didn't have flippers, so they pretty much were a game of chance. It was actual pins and the ball dropping through.
Oh, and then you'd bet on it. I see. Yeah.
But for up and through the 60s, into even the early 70s, it was illegal. They were deemed illegal in many states because they were considered a gambling machine. And so it wasn't until a guy named Roger Sharp, who I've met and talked with, showed the New York City commissioners or county commissioners, whatever, New York commissioners, that pinball was a game of skill. And
how much tax revenue they could get out of the pinball parlors.
Yeah, exactly. Well, that's true. But it'll be interesting. There's a movie coming out just for all you pinball reliability people called The Man Who Saved Pinball.
Wow, cool.
It'll be coming out soon, and you'll see it. But it's an interesting story of fear of these machines, and they didn't make them strong enough to withstand sledgehammers, which would be
people would use. That's how they destroyed them when they found them.
They smashed them when they found them.
Man,
machines.
Yeah, there's all kinds of stresses out there. If they would have built it in 2-inch thick titanium, they might have had a better chance.
Anyway, well, yeah. So we realize the need for. Let's just summarize that we need some kind of testing at the end of assembly, and some kind of inspections. But the key here is to pick the ones you have evidence are either marginal, that you need to focus on, either have been a problem in the field, or you found early in your testing of design and you can't really change it. Like you talked about the ring and the glue, that you really don't want to change it, that you didn't have to monitor these key processes and the key process indicators, and don't rely on inspection, as Deming always talked about. You'll never get 100%. That's for sure.
That's for sure. Yeah. And I would add, this other step is to respond to field failures expeditiously, and when you first launch a product, especially a volume product, is you got to get on it really fast, because you're making too many of them too fast.
And you probably won't get a lot of them back because they're probably inexpensive. I mean, I don't know. It depends on
on your policies and how much you do this stuff, but it's possible. But anyway, there's lots of things you can do. And I think thinking through what the priorities are and where you're going to invest to get the best return is the way to approach it. You just can't do everything, and it's folly to do nothing. So, But that was an interesting question that came through is, how do you go about doing this? And so there's one outline of it. I think I actually need to go amend my answer, because talking through it with you, Kirk, has made me think of a couple other things, and you brought up a couple. But that's the idea. If you've got a question, hand it on over and we'll get you a response, and then we'll probably talk about it one or more episodes on the show.
And it may change our
understanding and stuff. I think just having, folks you can go talk shop with is always a good way to learn and hash through ideas and challenge each other and stuff like that. But give us some fodder here to go chew on. Send us over your thoughts and questions or things that you're concerned about. We'd love to help if we can.
Especially new technologies. If you guys out there are dealing with new technologies, that's what I haven't kept up with as much, but we'd love to hear about any of those things.
And how they fail, especially. Right. All right, Kirk. Well, I should say, I've asked you to send the questions over. Go over to accendoreliability.com/go/SOR, and that will get you to a page that has a couple of ways to get in touch with us. Kirk and I and the other hosts are available through LinkedIn, and we have contact information on our About pages also on Accendo. So plenty of ways for you to get in touch, and we look forward to hearing from you.
Thanks, Fred.
All right. Thanks, Kirk. We'll talk to you soon.
All right. Talk to you later.
Cheers. Thanks for listening to Speaking of Reliability. We invite you to join the conversation. If you have a question or a topic that you think we should discuss in a future show, please let us know. You can find a comment box below the episode show notes, or just leave a note as part of a review on iTunes.